Hello everyone, myself Sukarna Dey Mondal. Today we are going to discuss Cauchy Euler differential equation. So here is the form: x squared d2y dx squared plus p1 x dy dx plus p2y equal to fx, where p1 p2 are constant and fx is a function of x, which is a second order homogeneous linear equation, and this differential equation is known as Cauchy Euler differential equation. So here is a method of solution. So here x squared d2y dx squared plus p1 x dy dx plus p2y equal to fx, where p1 p2 are constant and fx is a function of x. So we can write x squared d squared dy. Actually we are having d equal to ddx. So since we are having second order, so we can easily write x squared d square y plus p1 x dy, capital D, since we are having d dx, so dy dx, so we can rewrite dy plus p2y equal to fx. So after taking common y from the left hand side, we are having x square d square plus p1 xd plus p2 and outside y fx. Now let us consider the transformation x equal to e to the power z. So here log x equal to z. So dy dx we can write dy dz into dz dx. We can rewrite the line because we are having z in terms of z. So we have to include z. So dy dz into dz dx equal to 1 by x dy dz. So here, so if we cross multiply, so we are having x dy dx equal to dy dz. Next, let us consider dy dx equal to dy, capital D. Already we are having d means ddx, so dy, and d2 dy dz we are having d dash. So we are taking d dash means ddz. That already we have written. D dash means ddz. So here x dy, this means this one becomes x dy equal to d dash y. Next we are having d2y dx square, so we can rewrite ddx of dy dx, that means ddx of 1 by x dy dz. So after taking the differentiation, we are having minus 1 by x square dy dz plus 1 by x d2y dz square into dz dx. So finally we are having minus 1 by x square dy dz plus 1 by x square d2y dz square. So taking cross multiplication, left hand side we are having d2y dx square. So taking cross multiplication, x square will be in left hand side. So we are having x square d2y dx square plus equal to d2y dz square minus dy dz. So again we can rewrite in terms of d, capital D, since already we know that d means ddx. So x square d2y equal to, since here we are having dy dz in terms of this, so we can rewrite d dash into d dash minus 1 whole y. Now substituting the values of x dy comma x square d2y, we get this type of equation, which is linear equation with constant coefficient. So this solution is found by the method of solving linear equation with constant coefficient. So this is the general case. This way we are going to solve the remaining questions. So we are having on example. If I show you one example, it would be clear to you. So just see example. We are having x squared d2y dx squared minus x dy dx plus 4y equal to x sine log x. So we can rewrite the line x squared d2y minus x dy, since we know that d equal to d dx plus 4y equal to x sine log x. Now same as before, we should take one transformation, this one x equal to e to the power z, that means log x equal to z. So same way you will get the value. Actually the first order and second order are always same, whatever the question we are having. So this one x dy dx equal to dy dz, this one, and another one we are having this x square d2y dx square equal to d square y dz square minus dy dz. So this one, the previous value x dy dx equal to dy dz, and this one value always same. So if we are having question 7 marks question, so you should find out, you should show the result, what is the first order value, what is the second order value. But if we are having suppose 3 marks or 4 marks, so we can write directly this one and this one directly, because both are same in all the questions of Cauchy Euler differential equation. So this one is x square d2y equal to d dash minus 1 whole y. Now we are going to substitute. Where we can substitute, just see the given equation. We are having the given equation, this one. We are going to substitute. So after substitution, we are having, after simplifying, d dash square minus 2 d dash plus 4 whole y equal to e to the power z sine z. So which is linear equation. Now this is a second order equation, and all of you know that this type of equation we are going to find first CF then PI. Okay, so for finding CF, the usual thing is, in previous case we have seen, always we should take y equal to e to the power mx, but here there is no x. This is the usual thing, y equal to e to the power mx. So first in your mind it will come y equal to e to the power mx, but you have to check the equation, there is no x. So that's why we should take y. Okay. So y equal to e to the power mz. In place of x, it will be z. Since we are having y and z variable, so we have to keep in mind. So y equal to e to the power mz be the trial solution of left hand side equal to 0 for finding CF. So d dash square minus 2 d dash plus 4 whole y equal to 0. So the auxiliary equation be m square minus 2m plus 4 equal to 0, and you should write since e to the power mz not equal to 0. This line is very important. So we are having m square minus 2m plus 4 equal to 0. So m has two values, both are complex value. One value, if I take m1, so it will be 1 plus root 3i, another value 1 minus root 3i. So these are the two complex value. So the formula will be the case 3, already we have done, y is equal to e to the power alpha z. What is the value of alpha? Alpha means 1, so that's why directly we should write z. C1 cos beta x. What is the value of beta? Beta means here root 3, so root over 3x plus C2 sine root 3x. Okay, so e to the power z cos root 3x plus C2 sine root 3x. Okay, where C1, C2 arbitrary constant. Actually, here we should write e to the power z. E to the power mz we have taken, so you should write here C1 e to the power root 3z. Why? Because here y and z variable are present. Then you can write this equal to e to the power z C1 cos of root 3. What is the value of z you have taken? At the begin, go back. At the begin, what you have taken? Z equal to log x. So that will be appropriate. Okay. So you will write here log x plus C2 sine root 3 log x. Okay, this is your yc. Next your yp. Yp here, yp means 1 by d dash square minus 2 d dash plus 4 e to the power z sine z. Okay, just see, we are having e to the power z sine z. Okay, so we know the formula. If we are having sine function and exponential function, not sine function, remember e to the power x into v function. If we are having this type of formula, So e to the power x comes in front, this one, and d is replaced by e to the power here a. So d replaced by d plus a. So what is the value of a here? 1. So that's why d dash replaced by d dash plus 1. So d dash plus 1 whole square minus 2 into d dash plus 1 plus 4 sin z, same as before. So after that we are having d dash square, after cancelling all this thing, d dash square plus 3 sin z. And this is the formula, remember all of you, f of d square sin z. So d square replaced by minus a square. D square replaced by minus a square. So what is the value of a here? 1. So that's why d square replaced by minus 1 square. Just see minus a square. So what we are having? E to the power z sin z 2. Okay. So that one again, actually our question in terms of x. So your answer will be in terms of x. Okay, whatever we have taken in between the problem, z, p, q, so ultimate your answer will be in terms of x. So e to the power z, again go back the previous line, what you have taken at the beginning, e to the power x, e to the power z means x. So you will write here x sine log x divided by 2. Okay, so this one your yc, this one your yp. So the general solution yc plus yp. So just see, we have written ultimate or answer. This is your answer. This one your answer. This is your yc. Okay, I forgot to tell you this one. Whenever you will write here this one log x, you should write here also x. So that at last you can write also. So x into c1 cos root 3 log x plus c2 sine root 3 log x plus x sine log x by 2. Okay, so in this way we can find out Cauchy-Euler differential equation. At beginning we have to first transform into second order differential equation, then same as before yc plus yp, ultimate your general solution yc plus yp. Next, another question example, x square d2y dx square plus x dy dx minus y sine log x plus x cos of log x. Okay, we are having the same thing solution. Same way we can find out, just see x equal to e to the power z, log x equal to z. So first two part always same. Already I told you, first two part always same. Same thing, x dy dx, same calculation we are having x square d2y dx square equal to d2y dz square minus dy dz. And same way substitution, ultimate this will come. This is the second order differential equation. Okay, so then e to the power m, just see as already we have done y equal to e to the power mz. Remember here always e to the power mz, not e to the power mx. So what is the equation come? M square minus 1 equal to 0. So m has two value, plus and minus. Okay. In previous question we are having complex number. Now we are having distinct number 1 minus 1. So what is the complementary function? So we know that for finding complementary function we are having three cases. Okay. So this is the case 1 and the previous question belongs to case 3. So C1 e to the power z, here you can write C2 e to the power z, C2 e to the power minus z. Okay, you can also write C1 e to the power minus z plus C2 e to the power z, whatever we can write. And this is the PF, PI, YP, this way, just separate them. This formula is sine, so d square replaced by minus d square, and it is the same previous formula, e to the power ax into b. So this one ultimate you will get this calculation, and at the end of the value don't forget to put the first, as we have taken e to the power z equal to log x. So this one you should take e to the power z equal to x and z equal to log x. So the general solution yc plus yp, this is the answer. c1x plus c2 1 by x plus sine log x by minus 2 into x by minus 5 minus 2 sine log x plus cos log x. In this way, this is the third question, and this is for your homework. You will solve yourself. X square d2y dx square minus x dy dx minus 3y equal to x square log x. Okay, so all of you solve the question, and next class we will meet with new chapter with new differential equation method. Okay, so till then, bye all of you.